We're sharing screen. Okay, here we're gonna visit our website, zastro.lovable.app. Okay, I'm going to log in. Okay, now we're logged in. Let's switch to English. And here are some of my work I'm going to introduce to you. So first is our stereoscope processor, and that's the work I put most of my effort in for the past 6 months. And we're going to see how exactly it works. I'm going to hide this. So for most astrophotographers and amateur astronomers, you are probably already familiar with dealing with your deep sky images with stars only image and starless image. Um, this is pretty easy to do. You only need to use a plugin script called Star Exterminator, developed by RC Astro. So yeah, basically what it does is making this image look like this. You see all the stars are gone, okay? And you also have a developed star mask, all right? And that is our so-called stars only image. And the starless image is this, a deep sky image without stars. So yeah, now as we already have the two images, let's put in the LRGB stars of Orion Nebula, which I took 5 months ago. And now we're gonna put our starless image. I have many versions. So here, it's gonna take a bit. All right, they're both uploaded, and we can see both images in preview. As you can notice, there is some residue artifacts coming from our stars only image. This is what Star Exterminator cannot detect as part of nebula or nebulosity. So it remains in our stars only image. So what we're gonna do, there are two ways of doing it. So I developed this stars function component. You can see what it does. Okay, so basically it works kind of like our curves tool or histogram stretching tool in Photoshop. We'll need to click auto. As you can see, the nebulosity part is getting smaller. But if you're still not satisfied, you can either use an eraser tool to remove it completely. Here we're going to demonstrate. Okay, I'm going to remove it like this. So this works just like the clone stamp in Photoshop. You can shrink the brush size and get these removed as well. So here we go. Okay, now the blue dots, blue blobs are completely gone. But some of you say, oh yeah, that's not what I want because that's part of our nebula. I want it where the nebula is. And that's fine. We can just click, go back, reset, bring our nebulosity back. Okay, so what we can do now is the second function that I'm gonna introduce, which is the clip function. Okay, so this has never been done before by anyone else in this world. I'm pretty much the only one who's doing it. I'm just making the process easier. I'm not inventing anything. So let's see. So say this part of the nebula. So let's draw a shape, okay, with our mouse. You can go very precisely with this. Um, we'll need to circle it um, like this and close it. Okay, now it's been closed. We're going to give it 2 seconds for it to make selection. So now we click clip and see what happens. Okay, so now it's in our clipboard with image size right here. So this part, say we're gonna put it directly on our starless image, we'll need to click paste. Okay, now it's been pasted. All right, after you see this return button, it's been done. Okay, now we can close the window. And if you blow up this image, you're not going to see that much of a difference. I'm going to use another instance to introduce this, how exactly it works. Okay, we can do it again. Star functions. All right, let's go to our image. Let's find a relatively bigger star or group of stars. Okay, let's pan it. Okay, let's see this one. All right, it looks quite bright. It looks quite bright, and let's just center it and clip it. I want to select the whole star. Now we're not gonna avoid the smaller stars. Okay, let's include this whole group of stars like this. Okay, so we draw this lasso mask whatsoever. Um, give it a second. Now we have the shape. Click clip and paste. Okay, it's been done. Close. And now you can already see it. See? What is that? Right? It wasn't there before. Okay. And this is how it works. It works really well. You can just select what you want to put on the stars image from our stars only image and close it. And of course, we can withdraw it. We can undo our paste. Undo paste. Now it's back. See? Our star is back. I believe it was right here. Okay, let's click close. And let's look at our starless image. It's completely clean. All right? It hasn't been messed with. And now say we're happy with our results. We're moving on to our next step, which is to set our parameters for our final image. So let's just keep it on default, or you can shrink the border size a little bit to 50, and stereo spacing back to 150. Okay, now we're going to deal with our stars image first to create 15 layers of stars. And why 15 layers, I will have to explain it in the paper. I cannot just um, say it with my words because it's quite complicated. Okay, let's generate. Okay, and now the system is going to deal with all the stars from our stars only image. And it's going to take quite a while, about 1 or 2 minutes. As you already see, we have our starless image layer right here. and we're going to do a left or right displacement, Gaussian blur, to make it look slightly different in the left image and right image to create this parallax view for us to see the 3D structure of the nebulosity. Okay, now it's almost done with our um, multi-layer star depth. Okay, it's at level 4, layer 4, layer 5, all the way up to 15. It's basically putting all the stars in different layers for observation. This has not been done before by anyone else in this world. With a system that's so dedicated to detecting stars and grouping them. Okay, now you can see we have 15 images here. We're going to download all the layers because the file is quite big. We're going to take a few seconds. Okay, now we can see it. Let's open it. Oops, it's right here. Let's open up. Okay, now you can see we have our 15 images. So you can see that the way I group stars is based on size, brightness first, and then um, we're going to show you something else amazing. Okay, now you can see at layer 5, I believe this is this is layer 9, we have 359 stars. And for each layer, we have this counter to say how many stars are in the group. Okay. Layer 2, we have 67 groups of stars. As you can see, smaller stars that cannot be separated from the bigger star are recognized as a group, as a cluster. Okay. And this is because their brightness and other features are matching. So that's why in our algorithm, I'm putting them as a group, as a cluster. Okay. And you can also see like smaller individual stars in the back layers. They're really faint stars in the background. Now we're barely gonna notice. So 15 layers is quite enough for the purpose. As you can see, when we're at like 13 layers, oh my gosh, really faint. You have really have to blow it up to enlarge the image to see it. You zoom in, and that's more than enough for this purpose. Okay, now we're done. Say we have 15 layers of stars that we're happy with, and for the displacement amount, we have this format that does it for you. Basically, it measures the distance of our starless image, and it's going to decide how many pixels it's going to move. So Orion Nebula is around 1,500 light years away from us. So we're going to do a 25 pixel displacement. Let's just move it to 25. Okay, now say we're happy, we can just click generate. It's going to take 10 seconds or so because we have so many layers of stars. The system's going to take quite a while to detect and place them on all layers. See? Okay, still processing. Images are really large. You can see the resolution here. This is 6,000 times 4,000, around 4,000, and this one, the same size, is taken by a APS-C frame camera. And now we have our two images right here. So you can download just a stereo pair, or just a left image and right image, or the generated depth map based on the starless image or the stars only image. We have all of it. Okay, let's see. We have all files. It's gonna take a second. Well, if that doesn't work, okay, let's see. We'll just download them individually. Okay, now we have our stereoscopic image. And as you can see, the stars, they look perfect. Okay, more than perfect. Like over here, we'd notice the star is right by the horse head, right at the edge. And on the right, do you want to see where it is? Do you see it? Okay, as you can see, it's right here. It's right here. And for many people who don't understand astrophotography, okay, when you see this individual image, you would say, that looks just fine to me. I do not see any displacement. And that's right. You do not see it because the screening function already does it for us. You're not going to notice any um, artifacts from our displacement process because the algorithm just works so well. Yeah, for this purpose. You can see all the bright stars in the core, the Orion Nebula. And when you wear the goggles, you're going to see the most impressive deep sky image ever. Or it's not an image anymore, it's just a hallucination. See? No artifacts, just the perfect stars from your original image. And it has the intelligence to detect all kinds of star spikes with halos. Okay, yeah, that's our result. And let's call it. And there's something else you can do. It's called AI vision calibration. So what this does is that our basic rule of filtering stars is not perfect. Why is it not perfect? Because it's only based on brightness and size. As you can see, this group of stars, they actually need to be here with the nebula because it's so bright. Um, the system is gonna already put it on the first layer. I say now we want it on 15. Just kidding, on ninth or 10th layer. This is what we're going to do. We just click AI vision calibration. So this is going to take about a second, minute. Okay, it's building union. So we have same 15 layers with adjustment. And we're going to displace all layers all over again. See, now we have 20 stars to be relocated on different layers. And as here, you can see, can download the preview and see what our algorithm does. Okay, now you can see there are many differences between the original 15 stars, 15 layer of stars and the after. Okay, let's open the original, which is here. Okay, yeah. Okay, now this is original. You can see the Ryan clusters are here. And now, based on Gaia, on online database, they are put here on the, which layer is it? Oh, okay. Now we can see um, layer 3 and layer 8 called AI layer, which is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, around 9 or 10 layer, 10th layer. Okay. The bigger stars. And this is all based on the calculation of the distance between the stars and us. And the calculation is quite accurate. And now let's go back to our website to see what we do next. Okay, after this has been done, we have to click Generate 3D Images again for the new results. Okay, it's going to combine all the layers and make displacement. Okay. Yeah, it's taking much longer than before because it really is doing work. It's not kidding. Okay, now we have our new image. You notice the difference? Okay. Um, you saw the image just moved, right? Yeah, and that's our recalibration. It's probably unnoticeable with human eyes, but the scientific meaning behind this is quite significant. Um, and so by this, we can see where the stars truly are in stereoscopic vision. Okay, and now the same technique has also been applied in our 3D starfield generator. And what this algorithm does is to create um, an animation based on your starless and stars only image. Okay, now we have two images uploaded just like in stereoscope processor. And that's just, we can rotate it. Okay, let's rotate both 90-degree clockwise. Um, I just like it this way. Click process, and now we have it. Okay, now we have this animation with real stars based on their brightness and sizes. And some people are already satisfied and ready to go. You can just click render and download video if you're happy with that. But some people might say, oh, this is not scientifically accurate because the stars in Orion are not supposed to fly out. Okay, there are many ways to do it. So first, you can use our star functions tool to um, clip the Orion region of stars. Um, you might already know where they are and which stars um, are supposed to be there. Okay, let's pan down to the region. Okay, let's see. We can select and do what we just did and put it on the stars layer for the purpose. And now I'm just gonna close it. Let's say we're skipping this function. All right, that's fine. And here we have our multi-star star layer system ready. Um, I'm just going to call it alpha here because it's the alpha version. It's still in test. Okay, let's click generate. So it does exactly what it did in our stereoscope processor to group and relocate stars on different layers. So as you can see, it's taking quite a bit of time um, to do, but it's definitely worth the wait because in the end, you're going to have something really close to actual scientific data. Okay, now click play. You notice the difference, okay? And you see, oh, the stars are not flying out fast enough. Okay, let's see. Reduce the motion application to 110 and bring up authentic stars animation velocity up to 1.5. You see, oh, now the stars are flying out. I see, oh, now the stars in Orion, in the court of Orion, should not be flying like this. Okay, now we can do this to recalibrate calibrate with AI. Okay, this is going to take minute or two. It does what it just did in our stereoscope processor um, to relocate the stars, reassign the stars accordingly. Okay, all right. It's building layers now. It says it has detected 28 stars. Every time it's slightly different, but for most part, the star detection logic is built in our AI. And what it does, it finds all the closest stars to us and find their according layers, layers they should be on. They're supposed to be on, based on the parallax vision. Okay, we're at 21 now. I have 28 or 7 left. Now the stars have been recalibrated. Okay, let's bring this down a little bit. Ah, now we can see. Um, let's click this to bring zoom focus to Orion. You can see the stars are going and flying out with the nebulosity, which is quite close to the scientific fact. And that's where the newborn stars are in our Great Orion Nebula. Okay, yeah, this is it. This is the scientifically calibrated final result of a fly-through animation of Orion Nebula based just on your original images with no um, modification. This is it. Yeah, this is what we already always wanted to do as astrophotographers, and this representation, sorry, is the most accurate and artistic so far in the industry. Okay, we can spin it a little bit. Okay, say 5 degrees. Bring more dynamic elements in. And we can also do counterclockwise if you want. Okay, I think counterclockwise looks better. We can do spaceship effect. What this do? It will accelerate. It goes really fast, and then it will slow down. I'm gonna like the space travel, and we can close it. Okay, do warp drive. See what warp drive does. Okay, it goes faster than spaceship. Uh, so if we're really flying at that speed, at that rate, we'll be exceeding light speed already. So I also have this simulation called hyperspeed effect to pay homage to our Star Wars when we jump to hyperspeed. Okay, this is more artistic than scientific. So this is my interpretation of what the light speed might represent. Okay, you can see it's like wiggling, wiggle, wiggle. Okay, now we can turn it off. Yeah, it's back to normal. You can add this nebula fade in effect and fade in speed. We can bring it higher. Okay, now, well, I don't know. Some people like this, some people don't. We can do nebula fade out. Obviously, it does what it does. Okay, now we have only the stars. We can turn them both off, and we're going to introduce our artificial stars right now. Okay, you notice there are more stars in the image, in the preview. Um, and you click, they're off. They're not flying our direction. It's fake. And wait a second, let's only have to click, sync. And now they have been synced with our real stars. To say you want to add more stars to your final video, this is what you can do. And you can change the flight speed and color palette. You can do mix, blue giants, white dwarfs, yellow suns, red giants. Okay, but mix is most realistic. Okay, you can add the count or decrease the count to let's say 300. I think that's quite enough. Yeah, and we can do brightness range from minimum to maximum 30 to 100 and do 55 to 85. Okay, and